So far we've simplified, multiplied, and divided fractions. And just like in arithmetic, the next operation we're going to do is addition. The thing that makes adding and subtracting fractions a little more complicated is that before we can actually do the operation, we need to have a common denominator. We need the pieces to be the same size before we can add them. So we're going to spend a day just on the least common denominator before we move forward and add. So going back to arithmetic, if I say 3/7 is equal to how many 35ths? I could do the whole proportional thing of cross-multiplying, but it's much easier just to notice that what is 7 missing that 35 has? It's missing 5. In other words, if I multiply 7 times 5, I get to 35. If I'm going to put that on the bottom, multiply the bottom, I have to also multiply the top. So this is 15/35. In fact, I want to really use the language, what's missing, as we pursue this, because it will help us as we come to fractions that have polynomial denominators. The next example just takes it to the next level. It's 8 over 3a is equal to what over 18a squared? So what do I have to do to 3a to get to 18a squared? In other words, what's 3a missing that 18a squared is missing? Clearly it's missing a 6 because 3 times 6 is 18. And it's also missing an a because a times a gives me a squared. So I multiply by 6a, and the new numerator is 48a. By the way, when you do your homework, if you look up at the back of the book, it's only going to say this is 15 is the answer, or 48a. It doesn't do the rest. The final initial example I'm going to do is if I say 2 over x minus 5 equals what over x minus 5 times x plus 1. Do remember to put your polynomials in parentheses. That way you can see that this whole number is also shared over here in the denominator. So the only thing that's missing is x plus 1, x plus 1. So my new numerator is 2 times x plus 1. And you can just leave it in factored form. There's no reason to simplify at this point. So the next thing is to find the LCD of a group of fractions. So we're going to begin with a group of fractions with numerical denominators. 3/4, 11/30, and 7/45. Most of us don't know off the top of our heads what is the smallest number that each of these goes into. In other words, the least common denominator, as you know, is really just the least common multiple. So I'm going to put the steps up here because they're the same for arithmetic as they will be when we have algebra involved or variables. The first thing you want to do is factor the denominators. Just like if I were looking for the least common multiple, the fastest and easiest way is to understand what the prime factorization is. So 3 over 2 squared. This is 11 over 2 times 3 times 5. And this is 7 over 3 squared times 5. For it to be the least common denominator, I need a collection of factors that has all of these in it. If you think back to what we've done with prime factorization, that should make sense. So we're going to really practice this whole what's missing idea. If on this one I have 2 2's, I'm wondering what is this missing that any of these others have? So I already have 2 2's. I need 3 to the second, and I need a 5. 1 3 is not going to cut it. In order for this number to go in, it needs 3 to the second. So this one is missing 3 to the second times 5, and now I have to do it on the top as well. Now I'm going to look at the same thing. What is 2 times 3 times 5 missing that anything else has? Well, you can see it's missing a 2 and a 3. And that means I will be multiplying the top by 6. Finally, 3 squared times 5 is missing a 2 squared. So this 7 is by 2 squared. At this step of the game, we're not even interested in knowing what these multiply out to be. But you will you might be interested to know that this number now is the same because it's common, and we've found it as a common denominator because it is a collection of factors that covers, if you will, all of the factors in the individual fractions. That's what I mean by what's missing. And we're going to apply that now to what the polynomial, how it works with algebra, especially in polynomials. I will say that this, if you multiplied it out, is 180, and you know, it's really not that hard to see, but it's easier to proceed to if you factor it. So now I'm going to move on to the algebraic application of this. 6x minus 30 and 8 over 9x minus 45. I hope you remember over here, we'll just put it again, factor the denoms, and then we're going to ask what's missing. So the directions on this kind of problem are just find the least common denominator. So first we're going to factor. And you might want to always put your things in parentheses so you're not tempted to think of these as parts. This is an entire number, this is an entire number, and we have to work with it as such. The GCF of this is 6. That leaves us with x minus 5. The GCF of this is 9, leaving us with x minus 5. Well, some of you, it might help to know, or just to write out, that 6 is really 2 times 3 times x minus 5, and 9 is really 3 times 3 times x minus 5. So what this fraction is missing on the left is a 3, barely fits there, and if I do it on the bottom, I do it on the top. This one is missing a 2. If I do it on the bottom, I do it on the top. We're not actually required to do this at this stage because the directions were just find the least common denominator, but that means that this would be 18. The least common denominator is 18 times x minus 5. And the new numerators, even though I wasn't asked for that, are 9 and 16, because that's what we get when we multiply the top and the bottom. So now, let's take it to the next step. 9 over x squared minus 8x plus 16, and 5 over x squared minus 7x plus 12. Again, I think your factoring is solid enough at this point that it shouldn't be that hard. Remember, factor the denoms first. So, try, x, signs are the same. Numbers that multiply to 16 add to 8. Try, x, signs are the same. Multiply to 12, add to 7, 3, and 4. So you can see this is x minus 4 times x minus 4. This is x minus 3 times x minus 4. This one is missing x minus 3. If I do it to the bottom, I have to do it to the top. This one is missing an x minus 4. If I do it to the bottom, I have to do it to the top. And you know you're done when this collection of factors is the exact same thing as this one. So I'm just going to write that second step. What's missing? So these now are the two new fractions written with a least common denominator. 9 over x minus 3 times divided by, or over, x minus 4, x minus 4, x minus 3. And the second fraction is 5 over x minus 4 over x minus 3 times x minus 4 times x minus 4. Be sure you factor this completely and then figure out what's missing. Put that in the collection of factors on the bottom and then also multiply the top by that, because you can't just multiply the bottom of a fraction or the denominator. You've changed the value. Here's what really confused kids. If I say 1 over x and x over x plus 1. Here's another reason to put your polynomials in parentheses. This entire thing is a unit. It's a number. You can't break it up. So when I look for what's missing over here, it's missing the entire factor of x plus 1. And this one is missing the x. So that's what these would be. And written with a common denominator, x plus 1. And this would be x squared over x times x plus 1. You know you're done when the collection of factors is the same. And it's just important to realize you can't take a part of that. If I said to you x equals 5, x, the original denominator would be 5, and the other one would be 6. They don't have anything in common, so if I wanted to make it common, I'd have to multiply by the entire thing, which, as you see, is what we did. The x was 5. I multiplied it over here. And the x plus 1 was 6. I multiplied it over here. Similarly, if I have b over b plus 5 and 5 over b minus 5, these look like they're related, but as we know, they're not. It's b minus 5 is missing the whole thing, and this is missing the whole thing of b plus 5. There's another slightly confusing thing that we might have to do tomorrow. Do it today. If I say 1 over 5 minus x and x over x minus 5, I put my polynomials in parentheses, and I know that that's not the same number. However, if you remember, they are related. One of them is the opposite of the other. So if I rewrite this as 5 minus x, oops, I can take the opposite of this fraction and call this one 5 minus x as well. Oops. Okay, I'm running out of gas here. And now I have a common denominator. Easy peasy. More on that tomorrow.